Hi guys, in today's video we are going to learn about PriorityQueue and its implementation in Java. We'll also be doing some coding example to see how PriorityQueue actually works. So let's get started. So a priority queue is basically implemented on a FIFO data structure. FIFO means first in first out data structure, and the priority queue is used when we want to process the objects based on the priority. So for example, in case of integer, the number itself can set the priority. The smaller the number, higher will be its priority, and this type of priority queue is called min priority queue. We can also have max priority queue where higher the number, higher will be its priority. Priority queue can also be implemented in four ways, including array, linked list, heap data structure, and binary search tree. But we all know that the insertion and deletion time is the most efficient in heap data structure. So the most effective way to implement priority queue is heap data structure. So now let's see how heap implementation for priority queue works. Here you can see we have a list of elements which are stored in a heap. Since this is a min heap, the root is always going to have the minimum element. And so when the root element is deleted, all the elements in the list will rearrange, and again the smallest element will be accessed as the head or the root element. So these are the most common constructors and methods which we are going to use in our coding examples. So let's get to the coding part. So to use priority queue, we are going to need this package because the priority queue class is present in this particular package. First, we'll create an object for priority queue. I'm creating an integer type. Now I'll just try to add some elements to it. So add is the method which I'll use to add elements. So let's add maybe 10. So you can see I've inserted the elements in a very random manner. It's not sorted, but let's just try to fetch the elements now. So let's just check what is the top element on our priority queue. So to check the top element, we'll be doing, and there's a function to use to check the top element, which is pq dot peak. So you can see the peak function returns 5, which is the minimum element of all. Now let's just try to remove an element. So what we'll do is, to remove element, we use poll function. So ideally 5 should get removed. Let's check. So we can see 5 just got deleted. And now let's again check what is the root element in our priority queue. So again we'll do dot peak. Now the lowest element here is 10. So 10 should be the output. Let's check. Yeah, 10 is the output. So this is the basic functionality of priority queue. We can keep adding elements, and then we want to remove the elements are removed in a particular priority. And in the case of integers, the lower the number, higher will be its priority. Now what we can do is we can also try doing the same for some strings and see what happens. So here I'm doing string, and instead of this I'll add some names. So in the case of string, it will arrange the strings which are added in an alphabetical order. So let's just check it out. What is the top element? And the top element should be apple. So it's apple. Now let's just try to remove apple. So we'll do pq.poll. Apple got removed. Now we'll again try to do peak, and the next element should be grapes. So let's check. Yeah, it's grapes. So this is how it works in cases of string. Also, I'm gonna show you how we can iterate through the priority queue. So let's just make it more systematic now. what I'll do is first I'll print my priority queue to check what elements are there, and then I'll remove the top element, and then again check, and then let's just try to add something here, and then again check what is our PQ. So if we run this, first we have apple, oranges and grapes. Then we remove the top element using peak.poll, using pq.poll. The top element was apples. Because of the priority, it got removed. And then this is the list. And then we added one more element. And then we again printed this is the queue. So when we are printing the priority queue, we can see that there's no guarantee the priority queue is going to print in order. It's going to be random, or it's going to be in the insertion format. So from here we can derive a conclusion. Only when we are deleting the elements it will follow that priority rule, otherwise not. Now let's just see how we can iterate through the priority queue. And then we'll just use a while loop. It dot has next, and we just print dot next. Now let's see what the iterator gives us in output. So, so this is the output from the iterator. So now when we have seen the ascending order, how do we do descending orders in priority queue? So for descending order, this is the constructor which we can use. Let's just see how it works. I am on my previous example. What I'll do is I'll change this constructor, and we'll again start by integer case. And here I'll be passing collections dot reverse order. And here I'm gonna pass some numbers. Okay, so let's see what is our PQ right now. We can see it's in random order, not even in the insertion order. So let's see what is the top element. So ideally the top element should be the maximum element, since we are doing in reverse order. So it should be 60. Let's see. It's 60. Now let's try and remove 60. And again check our PQ and peak. So after removing 60, we are left with these elements, and 30 would be our top element. So this is in reverse order. We can do the same with strings quickly. So from this list, we can see the top element should be walnut. So let's first check what is the top element. So the top element is walnut. Let's remove walnut and guess what would be the next element. It should be orange. Let's again print. So the next highest priority element is orange. So till this point, we've already seen how we work with data types. Now next we'll see how to handle custom class objects. So to handle custom class objects, this is the constructor we are going to use. So let's run it through the code. So we'll start by creating a custom class first, and then my class will have two or more attributes. And then I'll create a constructor. And then we'll create a getter method. Yeah. So our custom class is ready. Now we'll create a priority queue object of our custom class type. So here in this case, we can see that we have a custom class type of priority queue, and there's no way natural ordering is gonna work in this case. So here we have to explicitly define how the priority for the custom class object should be set. To define the custom priority, we have to use comparator interface and override the compare method. So let's just create a comparator class which implements the comparator interface which will be of type fruit market. And now let's override the compare method, say f1 and f2. Okay, and then we'll just write a custom condition. So I want my class to have the priority in terms of ratings. So I'll be comparing the ratings here. So let's see f1 dot rating else. So if it's lesser, it will return 1, otherwise minus 1, and if both are equal, it will return 0. And on the basis of these numbers, the priority will get set in the priority queue. And now I want to use this comparator in my priority queue. So I'll pass the object of this comparator into my priority queue like this. So now let's just test it. So first we'll create the object of our fruit market and 15. Apple. So we created these four objects. Now let's just add these four objects to our priority queue. PQ dot add 4. So we've added the elements to the priority queue. Now let's just see if we are getting the expected element. So from the priority perspective, orange has the highest priority. So we should get orange. Let's see. So we can see we are getting orange. Now let's just remove orange and see if we are getting the next highest priority element or not. So the next fruit which we should get is apple. Yeah, it's working exactly as we expected. So first priority was orange, then we removed orange out of the queue, and then the next priority was apple, so we are receiving apple. So, guys, priority queue is a very important data structure, and it's being asked in a lot of interviews. Like, a lot of questions are there which can be easily solved using priority queues. I will try to make a video on what all type of questions can be solved using priority queue. But if you have any particular question on this video, then please comment and let me know. Thanks and happy learning.